Okay, so let's talk about a little bit about the carbon-carbon single bond. So we have a carbon-carbon single bond. Each carbon has different substitution. This carbon has, let's say, iodide, bromine, and hydrogen. Same thing for this one. We have hydrogen, hydrogen, bromine, bromine, iodide, and chlorine. Now I switched white and red because typically we use white for the hydrogen and red for bromine, but the white wouldn't show up easily on the picture. So that's why I switched. Now how would we use a model like this as a mirror image of each other, which we call enantiomers, on a paper? So when we draw the paper, the line between the two carbons, or the bond between the two carbons, sorry, we have the iodide and chlorine on the paper. So if you pretend this part here and this part here and this part here on my paper, and then bromine and bromine coming toward me, and the two hydrogen away from me. So the two bromine showing with the wedge or solid line, and the two hydrogen shown with the dashed line. Same thing for the mirror image. Iodide, carbon, carbon and Cl are on the paper. Br is coming toward us. Br is coming toward us. And this Br also coming toward us. And the H is going away from us. Now, if you look at this carbon here, we can see H is away from us. So we can ignore it and say 1, 1, 2, 3. I'm sorry, 1. No, I said the wrong thing. Bromine is not 1. Iodide is 1. 1, 2, 3. So if I turn this over like this, 1, remember this iodide, right? Bromine is 2, and this is 3. H, we ignore. 1, so this is counterclockwise, S. Same thing for the chlorine. This is number 2, bromine is number 1. So this is 1, 2, 3. So this would be also an S. So put this over here. So we can look at this here. By default, we also said before the hydrogen we can ignore. So if I put my numbers here, so I put number here, 4 and 4. So this is 1. I'm sorry, this is 1. Keep saying iodide. Iodide is 1. 2. Then carbon would be 3. So for the one carbon on the top, so carbon on the top, if I draw it, would be 2, 1, this is 3, right? So 1, 2, 3. This didn't show up now. Let's use a brown. So it's counterclockwise, so it would be S. Same thing for the bottom. So same thing for the bottom. We have, remember Br, we don't have iodide here, we have chlorine. So this would be 1, this would be 2, this is still 3. So if I draw this now, and we can ignore the 4, remember we ignored the 4. So this is 3, 2, 1. So if I follow that 1, 2, 3, is also an S. So the name for this compound would be 1S and 2S. 1, 2, remember we have 2 bromo, dibromo-1-chloro-2-iodoethane. So you have only 2 carbons. Now, practice this for the enantiomers. Remember, these 2 are enantiomers, or mirror image of each other. Mirror image of each other. Practice and see if you can get this name. 1R, 2R, 1,2-dibromo, 1-chloro, 2-iodoethane. Again, we talked about that in the past in my textbook. They have the same property. They have the same property, except when we put them in polarimeter and we measure optical activity. They're opposite each other. If, let's say, this is, I don't know the number. If the number for this, for the alpha is, let's say, I don't know what it is, but let's say minus 20, I'm guessing. So the alpha for this one would be plus 20. They would be opposite to each other as the optical activity goes. But everything else, boiling point, melting point, they're all the same. Except few compounds, I'll talk about them later on. They have different smell. But everything else is the same. Thank you for paying attention to this molecule.